Hi, thanks for joining me today. I've got a fun geometry problem mixed with a probability problem. So we have a unit circle here centered at the origin, and we've marked on this point x, which has coordinates -1, 0. Next, what we're going to do is take theta to be uniformly distributed between 0 and pi. So essentially, we're choosing a random number between 0 and pi. And then once we've worked out what that is, we're going to make y have coordinates cos theta sine theta. So maybe theta ends up being like this angle here, which is roughly, I don't know, 70 or so degrees. And so then that point there would be y. And what I'm going to do is connect x, y like this. And now what I'm going to do is choose the point z on the circumference of the circle to make the triangle x, y, z to be as big as possible. So just visually looking at this, z might have to be roughly here in order to make this thing here as big as possible. And now the question is, what is the expected value of the area of this triangle? So if you want to have a go at this problem, pause the video now and give it a go for yourself, but I'm going to just dive straight in here. Let's imagine we know what theta is. So for the time being, imagine we've already chosen what theta is, and y has this coordinate over here, cos theta sine theta, like so. So now, let's think about where we need to place z. Well, this guy here has a fixed length once we know what theta is. And if we remember, the area of a triangle is just half base times perpendicular height. If we think of this as our base, we just need to make the perpendicular height of our triangle as big as possible. And it's not too difficult to convince yourself that's going to be when z is about here, when this line here kind of passes through the origin, and this would be a right angle. So z would have to be here to make this triangle xyz have an area as big as possible, and this point here is just the midpoint, m of xy. Cool. So now we're going to work out the area of this triangle in terms of theta. So let's just call that a of theta. So we're just going to go half base, which is going to be xy, times the height, which is m to z, which I'm going to write as m to o plus 1. So this being o here, and obviously o to z here is just 1. Okay, now we just need to work out the values of these, each of these. So let's look at xy. Well, xy here is just, if you use the distance formula, the square root of 1 plus cos theta squared plus the sine squared of theta. So it's the change in x's squared plus the change in y's squared, all square rooted, just from Pythagoras. And if we simplify this, this is just the square root of 1 plus 2 cos theta plus cos squared theta plus sine squared theta. But of course, cos squared theta plus sine squared theta is 1. So all in all, this is just going to be 2 plus 2 cos of theta, like so. But now what we're going to do is recall a double angle formula, which remember says cos of 2a is just 2 cos squared a minus 1. So if I rearrange this, I get that cos squared of a is cos of 2a plus 1 over 2. And now, if I multiply both sides by 4, maybe I'll just squeeze this in up here, I get 4 cos squared a is 2 cos 2a plus 2. And so now, if I replace capital A with theta over 2, this becomes 4 cos squared theta over 2 equals 2 cos theta plus 2, like so, which is precisely what we have inside the square root. And so this is the same as the square root of 4 cos squared of theta over 2, and then taking the square root of this, that's just 2 cos of theta over 2. Now you might ask, well, do I have to worry about plus or minus? Well, the answer is no, because remember this is xy. Xy is a length, so it has to be positive. And thankfully, because theta is between 0 and pi, theta over 2 is going to be between 0 and pi by 2, and so cos of theta over 2 will definitely be positive. Okay, amazing. We've worked out what the length xy is. Now let's work out what the length MO is, and we'll get an expression for a of theta. Okay, so now to work out MO, we're going to do something very similar. Let's first work out the coordinates of M. Well, it's just the midpoint of xy, so we take the average of the coordinates So that would be cos theta minus 1 over 2. So we add the two x's and divide by 2. And the y coordinates average is sine theta over 2. And now to work out OM, again, we're just going to use Pythagoras alongside some trig identities. The trig identity we're going to use is cos 2a is 1 minus 2 sine squared of a. And so applying this here, it turns out that, and I'll leave the details for you to check yourself, but it turns out that this thing here just equals sine of theta over 2, like so, which is great. So now we can work out this area. So a of theta is just going to be a half times xy, which we worked out was 2 cos theta over 2, times mo plus 1, so this plus 1, so 1 plus sine of theta over 2, like so. The half and the 2 obviously cancel, so this is just cos of theta over 2, and then plus cos theta over 2 times sine theta over 2, which is just the same as a half sine theta. And so that's just using the fact that sine x cos x is the same as a half sine 2x. So another identity there. Amazing. So we worked out what a of theta is once we know what theta is. And so now we can use the law of conditional probability to help us work out the expected value, or the expected value of the area of this triangle. Okay, so the expected value of a, the area of this triangle, is now just going to be equal to the integral from 0 to pi of a of theta multiplied by the probability density function of this thing here, which is just 1 over pi, because this is a uniform distribution. And so therefore this is going to be 1 over pi times the integral from 0 to pi of cos theta over 2 plus a half sine theta d theta. And we can just evaluate this. This is 1 over pi times the integral of cos theta over 2 is just going to be 2 sine of theta over 2. And then plus a half sine theta, that will integrate to minus a half cos theta, like so, between pi and 0. When I plug in pi into this, 2 sine of pi over 2 is 2, minus a half cos of pi, well, cos of pi is minus 1, so this will be 2 minus a half, so that's going to be 2.5. So if I just put this over here, this is 1 over pi times 5 over 2, minus, then when I plug in 0, that's going to be 0, and then I get minus a half of 1, so this is going to be minus a half. And 5 over 2 minus a half is 3, and so this is just 3 over pi. So the expected area of this triangle is just 3 over pi, which I think is quite a nice little result there. So obviously slightly less than 1. If you have enjoyed this video, please do give it a like, and if you're new to the channel, please do subscribe as well. Recently hit 5,000 subscribers, which I'm very, very grateful for, and hopefully I can continue to grow. Thanks so much for watching. I'll catch you in the next one. Have a great day.